Hi students, welcome to Preliminary Chemistry and the final video in the energy series. This is number 16. We're just going to have a quick look at catalysts. In the last video we looked at some of the factors that affect chemical kinetics or the rates of reactions. There was one that I left out. We did talk about temperature as a very important factor. We talked about surface area or concentration as also important factors, depending on whether we've got solids or whether we've got solutions or gases. And also pressure for gases is very important, pressure, volume, and so on. But one factor that I left out that has a big impact on reaction rate are catalysts. Now, catalysts are substances which can increase the rate of a reaction without actually being changed by the reaction. They're participants that help facilitate the reaction without themselves actually undergoing a chemical change. What the catalysts do is they help to break down the bonds in one of the substances in order to help it to rebond to the other substance more readily. In practical terms, and certainly in terms of how we have been setting out our progression of chemical reactions in terms of energy and energy profiles, what the catalysts do is they lower the activation energy. So they bring down the energy of activation. Let's see how this looks on an actual graph. So if we have a fixed temperature, the catalyst is going to ensure that at that temperature, the highest proportion of particles possess sufficient energy in order to react. That is, they exceed the activation energy. What they do is rather than bring the energy of the particles up, they lower that activation energy. So what you can see is a grid, again, like the one that we've drawn previously, with a reaction path on the horizontal axis and just energy on the vertical. As the reaction proceeds, we have reactants on the left-hand side that are going to rise to a level of activation and then return to the products. And so our value from here to here is our energy of activation. Now, what the catalyst is doing is it is changing the pathway. So it doesn't change the amount of energy of the reactants, they're the same. It doesn't change the amount of energy of the products, they're the same. Therefore, the delta H value here, that's a bit hard to see, the delta H value is also going to be the same. It doesn't change. What does change is this, the value of the energy of activation. It is what has changed. So the effect of a catalyst is to lower the energy of activation. And this is going to significantly increase the rate of reaction. For a substance to be classified as a catalyst, then it must firstly cause the reaction to proceed at a faster rate than it would otherwise proceed. So usually we would measure that against a control. And also it must not be used up or changed by the end of the reaction. It must return to its original form and can potentially then be reused over and over again. One other thing that you may be asked about in terms of catalyst is just some examples, and we will look at some of these in a lot more detail in the HSC course. But for the moment, three important ones which you might want to have a little bit of a look at are the production of ammonia in a process called the Haber process, and an iron-based catalyst is used to facilitate this change. The manufacture of nitric acid, HNO3, uses a platinum catalyst, and the production of ethyl acetate uses a sulfuric acid catalyst, and this is a dehydrating agent. In terms of nomenclature, when we are writing out an equation for this, so the Haber process, for example, is hydrogen gas plus nitrogen gas produces ammonium gas. And our iron catalyst, to show that it's there, is going to sit on the arrow, okay? It's going to sit there because it's not a reactant and it's not a product. It's not actually something that sits on the reactant side, nor does it sit on the product side. It stays here, and that helps us to show what's actually participating in this reaction, helping to facilitate the reaction, but is not actually being changed as a consequence of this reaction. So this is where we're going to put our catalysts. That's the kind of the main stuff that you need in terms of reaction kinetics. Understand the different factors that can increase the proportion of collisions that are going to result in a chemical reaction, either by making more particles, speeding up the particles, pushing them into a smaller area, or facilitating that reaction by lowering the amount of energy they need by using a catalyst. That's the end of the course, and thank you for watching all of these videos. We will start our HSC course in next term. So good luck.